Hi, dear students. In the previous class, we studied the properties of a determinants. Just today, we'll solve or we'll evaluate some determinants based on these properties. Before that, let me recap the properties once. Here, one we have if rows and columns of a determinant are interchanged, the value of the determinant remains same. ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಡಿಟರ್ಮಿನೆಂಟ್ ನ ರೋಸ್ ಅನ್ನ ಕಾಲಮ್ಸ್ ಅನ್ನ ಇಂಟರ್ಚೇಂಜ್ ಮಾಡಿಕೊಂಡ್ರೆ the value of determinant remains same. Determinant remains same. Here that is determinant of a dash is equals to determinant of a. Determinant of a dash is equals to determinant of a. So number 2 we have if two rows or two columns are interchanged, then the sign of the determinant changes. The sign of the determinant changes. Number 2 we have the sign of the determinant changes if you interchange two rows or two columns. So that means delta is equals to minus delta 1 or delta 1 is equals to minus delta. Next, third one we have if two rows or two columns are identical, that is same. Two rows or two columns are same, then the value of the determinant becomes 0. The value of the determinant becomes what? 0. ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಡಿಟರ್ಮಿನೆಂಟ್ ಅಲ್ಲಿ two rows ಅಥವಾ two columns ಸೇಮ್ ಇತ್ತು ಅಂದ್ರೆ then the value of this determinant is 0. Next, fourth one we have if each element of a row or column multiplied by a constant k, then the value of the determinant is multiplied by k. So that is if a1 a2 a3 b1 b2 b3 c1 c2 c3, if each element of a row or column are multiply k, so k, then that is equals to k into determinant of that is a1, a2, a3, b1, b2, b3, c1, c2, c3. Right? Here is the most important property. You should remember. Here you can take any common factor from any one row or any one column. That means this can be written as take out the constant that is k, common factor outside the determinant. Therefore, that is k into determinant of a1, a2, a3, b1, b2, b3, c1, c2, c3. You can take any common factor from any row or any column. We should remember this. Therefore, we have here that is determinant of ka. Determinant of ka can be written as k to the power of n. K to the power of n into determinant of a, where n is the order of the determinant, order of the matrix. So determinant of k can be written as k to the power of n into determinant of a, where n is the order of the matrix. N is the order of the matrix. You should remember that. Next again, a determinant of a skew symmetric matrix of order means 1 or 3, 5, something 7 order. The determinant of a skew symmetric matrix of order is 0. You should remember, for example, symmetric matrix of order 3. So that is 0, minus 5, 4, 0, again, sorry, this is minus 5, 5, 0, again 6, minus 4, minus 6, 0. It is a skew symmetric matrix of order 3 by 3. Then determinant of it is equals to A. Then what is the determinant of A? It is equals to 0. Is equals to 0. You should remember this. Okay. Next. So next property we have, if all the elements of a row or column are 0, then the value of determinant is equals to 0. ಅಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಡಿಟರ್ಮಿನೆಂಟ್ ಅಲ್ಲಿ ಒಂದು ರೋ ನ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ ಒಂದು ಕಾಲಮ್ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ 0 ಸಿಕ್ತು ಅಂದ್ರೆ ಅದರ ಎಂಟೈರ್ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ 0 ಆಗುತ್ತೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ವಿ ಹ್ಯಾವ್, here if in a row or column elements of a row or elements of a column are sum of two terms, then we can express such a determinant has a sum of two determinants. For example, that is determinant of a1 plus lambda 1, a2 plus lambda 2, a3 plus lambda 3, b1, b2, b3, c1, c2, c3. Now this can be expressed as sum of two determinants, that is equals to a1, a2, a3, b1, b2, b3, c1, c2, c3 plus determinant of lambda 1, lambda 2, lambda 3, b1, b2, b3, c1, c2, c3. If a row has sum of two terms, or column is each element of a row or column is sum of two terms, then such a determinants can be expressed as sum of two determinants. Next we have ಯಾವುದೇ ಒಂದು ರೋಗೆ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿಬಿಟ್ಟು ಯು ಕ್ಯಾನ್ ಆಡ್ ದಟ್ ವಿತ್ ಎನಿ ಅದರ್ ರೋ, ಆರ್ by multiplying a constant in one column you can add that with any other column and subtract. Okay, so any row, ಯಾವುದೇ ಒಂದು ರೋಗೆ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿಬಿಟ್ಟು ಆ ರೋ ಅನ್ನ ತಗೊಂಡೋಗಿ ಬೇರೆ ರೋ ಅಲ್ಲಿ ಆಡ್ ಮಾಡ್ಕೋಬಹುದು, ಇಲ್ಲ ಅಂತಂದ್ರೆ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡಬಹುದು. ಓಕೆ, ನೆಕ್ಸ್ಟ್ we have next property we have, if one side of a principal diagonal elements is upper side or upper side, then the value of determinant is equals to product of principal diagonal elements. You should remember this again. If one side of a principal diagonal, upper side or lower side, if all the elements are 0, then the value of determinant is the product of principal diagonal elements. You should remember this also. Okay, next, if A and B are square matrices of order same, then determinant of AB is equals to determinant of A into determinant of B. If A and B are symmetric, if A and B are square matrix of order same, then determinant of AB can be written as what? Determinant of A into determinant of B. Determinant of A into determinant of B. Okay, so these are the properties we have. So now, using these properties, we'll solve some determinants. So we'll see some problems. If A is a square matrix of order 3, comma, determinant of A is equals to 5. Again, comma, find determinant of 3A. Find determinant of 3A. Here, if A is square matrix of order 3, comma, determinant of A is equal to 5, then find the determinant of 3A. Determinant of 3A. So, now, we have to find what the determinant of 3A. Determinant of 3A. See, now this is in the form of K, determinant of KA. Determinant of KA. We know that this can written as K to the power of N into determinant of A. K to the power of N into determinant of A. We know the value of N. What is the value of N here? Order. What is the order here? 3 has given. So that is given N is equals to 3. N is equals to 3. And determinant of A is equals to 5. So now we have to find what? Determinant of 3A. Therefore, that is equals to 3 to the power of N into determinant of A. That is equal to what are the value of N? It is 3. That is 3 to the power of 3 into determinant A value. What is determinant A value? It is 5. That is 5. Okay. Again, we have to go for simplification of this. That is so 3 to the power of 3 means 3 into 3 into 3. Multiply 3 by 3 times 3 into 3. 9 into 3. 27. That is 27 into 5. That is equals to 27 to 5. 135. 135. Next question. If A is a square matrix of order 2, comma, determinant of A is equal to 5, comma, find determinant of 2A. It is determinant of 2A. Same, they are given that N is equals to order. So what is the order here? That is 2. The N is equals to 2. So determinant of A is equals to 5. So we have to find the determinant of 2A. Again, it is in the form of determinant of KA. We know the formula for determinant of KA. So determinant of KA can be written as K to the power of N into determinant of A. You should remember this formula. So determinant of KA can be written as K to the power of N into determinant of A, where N is the order of the given matrix. Okay. So here again that is equals to 2 to the power of N into determinant of A. Again that is equals to 2 to the power of, what is the N value here? That is 2 has given. A is the square matrix of order 2. That is N is 2. Determinant of A, that is 5. Again that is equals to 2 to the power of 2. 2 into 2, that is 4. Okay. So 4 into 5, that is equals to 20. Next, using properties of determinants. Those the properties of determinants without expanding through that So number 1 is my determinant of K minus B, B minus C, C minus A, B minus C, C minus A minus B. Again, C minus A minus B, B minus C is equals to 0. So now we have to prove that determinant of this is equal to 0. This is equal to what? 0. Without expansion, we must use what? Properties. Okay. Expansion antevre. Number 2. First row into first element into determinant of this minus second element to determinant of this again plus this element into determinant of this. ಅದು expansion method ಆಯ್ತು. ಅವನು ಹೇಳ್ತಾನೆ without expanding ನಾವು expand ಯೂಸ್ ಮಾಡಬಾರದು, ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ಕೋಬೇಕು. So we'll solve this. Now consider the LHS. What is LHS? LHS is equal to determinant again, determinant of a minus b, b minus c, c minus a, b minus c, c minus a minus b. Again c minus a minus b, b minus c. Okay. So use the properties. Use the properties to solve this question. Okay. So we have, so add this first column, second column, third column. A minus b minus adding plus b minus c plus c minus a. Right? That is right. C1 is replaced with C1 plus C2 plus C3. Adding, replacing the column 1 with adding column 1 plus column 2 plus column 3 elements. Right? So here that is equals to determinant of, we'll add this also an element, that is adding this plus this plus this, adding the corresponding elements. ಆ corresponding elements ಅನ್ನು add ಮಾಡಿ ಇಲ್ಲಿ replace ಮಾಡೋದು, ಈ corresponding add ಮಾಡಿ ಇಲ್ಲಿ replace ಮಾಡೋದು, ಈ corresponding elements add ಮಾಡಿ ಇಲ್ಲಿ replace ಮಾಡೋದು. We'll add this, that is a minus b plus this element b minus c again plus c minus a, c minus a. Right? What is a? This is a minus b plus b minus c plus a, get cancels. What are the remaining values? 0. Okay. All right. Here that is a minus b plus b minus c again plus c minus a corresponding elements. So that is again b minus c plus c minus a plus a minus b, again this c minus a plus b, a minus b plus b minus c. Write this columns as it is, that is b minus c, c minus a minus b. Again this column, that is c minus a minus b, again b minus c. Again that is equals to here plus a minus b plus b, this we cancel. Again that is equals to 0. Here plus b minus c plus c minus a, it cancel 0. Again c minus c cancel, minus a plus minus b plus cancel 0. Again that is minus b minus c minus a minus b. So c minus a minus b, b minus c. Okay. See here, the first column has 0 elements. Therefore, what is the value? You know, one property. If all the elements of a column elements are 0, then the value of determinant is equal to what? 0. That is equals to 0, is equals to RHS. Here, remember one thing, you can add columns or add rows. You can add 2 rows or 2 columns, or you can subtract 1 column with the other column or 1 row with the other row. So you can apply both row operations as well as column. Whereas in finding the inverse of element in matrices, to find the inverse of element, you used to apply only row operations or column operations. But here you can mix up both. Okay. So next question, it is determinant x, y, z, a, b, c x plus a, y plus b, z plus c is equal to 0, is equal to 0. So try, you have to expand, you have to show that determinant of c equal to what? 0, right? So add columns. You here, if you add columns, here 2a plus x, 2b plus y, 2c plus z, you can't take common outside. We have a property. If each element of a row or column is sum of two terms, then we can express the determinant as sum of two determinants. ಯಾವುದೇ ಒಂದು determinant ನ ಒಂದು ರೋ ಅಥವಾ ಒಂದು ಕಾಲಮ್ ಅಲ್ಲಿ sum of two terms ಇದ್ದಾಗ ಆ ಒಂದು determinant ಅನ್ನ it can be expressed as sum of two determinants. Use that property. Again, that is equals to, so that is x, y, z, a, b, c. This is sum of two determinant expressing, that is x, y, z. Again, plus, write this as it is. That is x, y, z, a, b, c. Next, that is a, b, c. So again, it is equal to 0 plus 0. Can you tell me why? Can you tell me why? Think here. First column and third column are identical, same. So ನಮ್ಮ ಪ್ರಾಪರ್ಟಿ ಗೊತ್ತಿದೆ. ಯಾವುದೇ ಒಂದು ಡಿಟರ್ಮಿನೆಂಟ್ ಅಲ್ಲಿ ಟೂ ಕಾಲಮ್ಸ್ ಅಥವಾ ಟೂ ರೋಸ್ ಸೇಮ್ ಇತ್ತು ಅಂದ್ರೆ ಅದರ ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತೆ? 0 ಆಗುತ್ತೆ. No need to expand. Again, come here. See here, second column and third column elements are same, A, B, C, A, B, C. Therefore, again, this becomes what? 0. So, it is equal to 0. It is equals to RHS. Next question, we have determinant of x plus y, y plus z, z plus x, z, x, y, 1, 1, 1 is equals to 0. Once again, we have to show this determinant is equal to what? 0. Of course, it is sum of two terms. If you express this as a sum of two determinants, you won't get that. So x z 1, y x z, z y x, you can't get that. Okay. So now add these two rows. That is, we know we have to replace r1 is equals to r1 plus r2. So ನಾನು ಏನು ಮಾಡ್ತೇನೆ ಈಗ ಈ ರೋ 2 ಅನ್ನ ರೋ 1 ಅನ್ನ ಆಡ್ ಮಾಡಿ ರೋ 1 ಅಲ್ಲೇ ಬರ್ಕೊಳ್ತಾ ಇದ್ದೀವಿ. So that gives, that is x plus y plus z, adding row 1 with row 2. That's our row corresponding elements of row 1 is added with the row 2. So that is x plus y plus z. Again here y plus z plus x, that given as x plus y plus z. Again this plus this, that is x plus y plus z. Right, the root has this z, x, y. Again 1, 1, 1. Right. So we know a property. We can take a common factor outside from any row or any column. ಈಗ ನಾ ಫಸ್ಟ್ ಕಾಲಮ್ ಇಂದ ಎಂಟೈರ್ ಟರ್ಮ್ ಸೇಮ್ ಇದೆಯಾ? Take the common outside. So that is equals to, that is x plus y plus z. It determinant of, we have taken x plus y plus z outside. 1. Here also 1. It also 1. Therefore z x y 1 1 1. Okay. Again that is equals to x plus y plus z already here. That is equals to x plus y plus z of 0. Why? Because first row and last row are, that is first row and third row are identical, same. So therefore 0. That is equals to 0. Is equals to RHS. While expanding properties, while expanding determinant using properties, ಯಾವ ರೋ ಅಲ್ಲಿ ಯಾವ ರೋ ಬೇಕಾದ್ರೆ ಹಾಡ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಯಾವ ಕಾಲಮ್ ಅಲ್ಲಿ ಬೇಕಾದ್ರೆ ಯಾವ ಕಾಲಮ್ ಆಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. See that two columns and two rows and make it as identical. Make it as identical. Next, determinant of 1 1 1. BC, CA, AB. A of B plus C, B of C plus A, C of A plus B, A plus B is equals to 0, is equals to 0. Then read B plus BC plus AB plus AC, and just multiply this to B and C to get AB plus CA, right? Here also get CA, BC, AB. You get these two terms as what? Same term. Then you can take the common factor outside. ಎರಡು ಕಾಲಮ್ಸ್ ಅನ್ನ ಆಡ್ ಮಾಡಿಕೊಂಡ್ರೆ ನಮಗೆ ಬರುತ್ತೆ ಸೇಮ್ ಟರ್ಮ್ಸ್ ಬರುತ್ತೆ. ಸೊ ಆಗ ನಾವೇನ್ ತಗೋಬಹುದು, ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ನ ಆಚೆ ತಗೋಬಹುದು. ದಟ್ ಈಸ್ C2 or C3. C2 gives rise to C2 plus C3. Again that is equals to, that is column 1 ಆಗಿರುತ್ತೆ 1 1 1. C2 gives rise to C2 plus C3. What is C2 here? That is BC plus multiply into what is before AB plus AC. Again adding this, that is CA plus BC plus BA. Again that is AB plus CA plus CB. CB, right? This as it is. Therefore, that is A of B plus C, B of C plus A, again C of A plus B, A plus B. So we have same terms, BC, BC, AB, AB, AC. Okay, same terms. Now you can take this from second row outside. Therefore, that is equals to, so BC plus AB plus AC, AC into determinant of 1 1 1. Now we will common factor ತಗೊಂಡಿದ್ದೀರಿ. What is the remaining value? 1 ಇರುತ್ತೆ. ಇಲ್ಲಿ common factor ತಗೊಂಡಿದ್ದೀರಾ 1 ಇರುತ್ತೆ. ಇಲ್ಲಿ common factor ತಗೊಂಡಿದ್ದೀರಾ 1 ಇರುತ್ತೆ. So therefore A of B plus C, right, as it is. B of C plus A, right, as it is. C of A plus B, A plus B. Okay, again that is equals to BC plus AB plus AC of 0. Again, because first column and second column are same, that is equal to 0, is equals to RHS. Next one, determinant of 102, 18, 36, 36, 1, 3, 4, 17, 3, 6 is equal to 0. You got to show that distributed is equals to 0. Here that is equals to, now I'll write this in multiples of 17. That is, we have 17 into 6. This can be written as 3 into 6. 3 into 6 again. This can be written as 6 into 6. 60 into 6. Write this as it is. 1, 3, 4, 17, 3, again 6. ಹೌದಾ? So ಇದನ್ನ 17 into 6 will get what? 102. Again 3 into 6 will get 18. 6 into 6 will get 36. So now you can take the common factor 6 outside the determinant. Outside the determinant. Therefore, there is equals to 6 into determinant of 17. Right? 3, 6, 1, 3, 4, 17, 3, 6. That is equals to 6 into 0. 6 into 0. That is equal to 0. Is equals to RHS. Is equal to RHS. Because first row and last row are same. Next one. Determinant of 2, 3, 5, 7, 8, 9, 65, 75, 86 is equals to 0. ಸೊ ಇದನ್ನ ಕಾಮನ್ ಫ್ಯಾಕ್ಟರ್ ತಗೊಳ್ಳಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ, ಇಲ್ಲ ಎರಡು ಹಾಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಬರ್ತಾ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲ ಇದಕ್ಕೆ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬಿಟ್ಟು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, ಅದು ಈ ಎಂಟೈರ್ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಬಿಟ್ಟು ಇದಕ್ಕೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಲಿಕ್ಕೂ ಹಾಡ್ ಮಾಡ್ಲಿಕ್ಕೂ ಟ್ರೈ ಮಾಡಬೇಕು. ಆರ ಇದಕ್ಕೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಇದಕ್ಕೆ add or subtract. See that you have to make two columns or two rows identical, right? So again I'll write like this, that is equals to, see I'll multiply 9 to this, ಈ ಕಾಲಮ್ ಗೆ 9 ಅನ್ನ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿಬಿಟ್ಟು ಇಲ್ಲಿ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತೀನಿ. multiply 9 to second column and subtract with the third column and replace with third only. So therefore that is C3 gives rise to C3 minus 9 times C2, 9 times C2. Now we will get 2, 3, 5. Okay, so now that is equals to determinant of, right, the C1 has it is 2 or 3, 5. C2 nage barkoltini 7, 8, 9, right? So ಈಗ C3 minus 9 times C2, that is what is C3 here? 65. 65 into 9 times corresponding C2 ಏನಿದೆ 7, right? So that is 7. Okay, so 65 minus 63 minus 63 again 65 minus 63 gives what? 2, that is 2, right? Now come next element 75, that is C3. 75 minus 9 times it's a corresponding element, 9 times it's corresponding element. Okay, so that is 8. Okay, again once again, so 75 minus 9 into 8, 72. 75 minus 72 gives what? That is 3. Again, so 86, apply this rule. 86 minus 9 times its corresponding element, that is 9. Okay, therefore 86 minus 9 into 9, that is 81. That is equals to 86 minus 81 gives what? 5. Okay, again just multiplying 9 to this column and subtracting with this. Okay, you'll get what? 2, 3, 5. Again that is equal to 0. Why? Because the first column and the last column are identical, same. That is equals to RHS. Next, determinant of A, B, C, A plus 2x, B plus 2x, sorry 2y, 2y, again C plus 2z, 2z, x, y, z is equal to 0. C and graph shows determinant of is equals to 0. Apply properties. So here the second row is sum of two terms. Therefore, we will express this matrix as sum of two determinants. That is equal to A, X, B, Y, again C, Z, plus determinant of remaining, that is A, 2x, X, again B, remaining, that is 2y, Y, again C, 2z, Z. Okay, so again that is equal to, write this as it is A, B, C, A, B, C, X, Y, Z. Okay, plus here from second row you can take the two common factor outside. Therefore that is 2 into determinant of A, B, C, X, Y, Z, X, Y, Z. So that is equals to 0 plus 2 into 0, 0, because here first row second row identical, here second row third row identical, 0 into 2, 0. This is 0. So is equals to 0. Is equals to RHS. Next, we have prove that determinant of 1 plus x 1 plus y is equals to x into y. Prove that determinant of 1 plus x 1 plus y. We have to prove that determinant of is equals to x into y, not 0. X into 1 to LHS is equals to RHS. Okay. So now consider the LHS. What is LHS? LHS is equals to 1 again 1 plus x 1 plus y. Sorry, ಈ ತರ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೊಟ್ಟಾಗ just try to make any two elements 0. ಯಾವುದೇ ಒಂದು ರೋ ನ ಅಥವಾ ಒಂದು ಕಾಲಮ್ ಅನ್ನ ಎರಡು ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನು 0 ಮಾಡಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡಿ. ಓಕೆ, ಸೊ here ಸೊ ಇದನ್ನ 0 ಮಾಡ್ಕೋಣ, ಇದನ್ನ 0 ಮಾಡೋಣ, ರೈಟ್? ದಿಸ್ ಅಂಡ್ ದಿಸ್. ಸೊ ನಮಗೆ ಇದನ್ನ 0 ಮಾಡ್ಕೋಬೇಕು ಅಂದ್ರೆ ಈ ರೋ ಅಲ್ಲಿ ಇದನ್ನ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡೋಣ, ಇದನ್ನ 0 ಮಾಡಬೇಕಾದ್ರೆ ಕೂಡ ಈ ರೋ ಅಲ್ಲಿ ಇದನ್ನ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡೋಣ. ಓಕೆ, ಸೊ ರೈಟ್ ಲೈಕ್ ದಿಸ್, ದಟ್ ಈಸ್ ರೋ 2 gives rise to ರೋ 2 minus ರೋ 1. ರೋ 2 ಅಲ್ಲಿ ರೋ 1 ಅನ್ನ ಸಬ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡೋದು. ಸಿಮಿಲರ್ ಆಗಿ ರೋ 3 minus ರೋ 3 gives rise to ರೋ 3 minus ರೋ 1. Okay, again that is equals to determinant of. So here write the row 1 as it is, that is 1 1 1. What is this? Row 1 minus row 2 minus row 1 minus 1 0. So now this one, so that is 1 plus x minus 1. This cancel. What is the remaining value? X. Again come to this 1 minus 1 0. Again come to this R3 gives rise to R3 minus R1. That is this minus this 1 minus 1 0. 1 minus 1 0. So that is 1 plus y minus 1. It cancel y. Okay. Again that is equals to. So here one side of the principal diagonal, all the elements are 0. We know that then the value of determinant is 1 into x into y. That is product of principal diagonals, right? What are the product of principal elements of 1 x y? 1 into x into y, that is x y. That is equals to RHS. So dear students, ಈ ತರ ಕ್ವಶನ್ಸ್ ಕೊಟ್ಟಾಗ ಫಸ್ಟ್ ನಿಮಗೆ ಚೆಕ್ ಔಟ್ ದ RHS, ಏನ್ ರಿಸಲ್ಟ್ ಬರಬೇಕು, ಮತ್ತೆ ಟ್ರೈ ಟು ಮೇಕ್ ಒನ್ ರೋ ಎಲಿಮೆಂಟ್ಸ್ ಆಸ್ ಒನ್ಸ್. ಒಂದು ರೋ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ ನ 1 ಬರ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲ ಒಂದು ಕಾಲಮ್ ನ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ 1 ಬರ ಮಾಡ್ಕೊಳ್ಳಿ. ದೆನ್ ಆದಾಗ you try to make these two elements as what? 0. You will get the answer. Okay, right? Thank you, man. So remaining we will see in the next class.